The EPA's Multifamily High-Rise Program offers eligible buildings 2 paths to earning the Energy Star. The webinar for the performance path should be viewed prior to the Simulation Guidelines webinar. If following the prescriptive path, this webinar is not needed. This webinar should be viewed by the energy modeler, although other members of the design team may also find it beneficial to their overall understanding of the program. Having a printed copy of the ASHRAE 90.1 2007 standard and simulation guidelines during this presentation is recommended. In the Performance Path webinar, you were introduced to the performance target, simulation guidelines, performance path calculator, and modeling checklist. This webinar will explain how to develop the building energy models needed in the performance path using ASHRAE 90.1 Appendix G and the simulation guidelines. This webinar will provide greater detail on creating the actual energy models without providing instruction for any specific software. A separate webinar is available for learning how to use the performance path calculator to determine specific model inputs and reporting results, which can be used in conjunction with approved modeling software. In order to create a baseline building energy model, you will first need to become very familiar with ASHRAE Standard 90.1 2007. Most HERS raters are familiar with the ResNet standards that govern the characteristics of the baseline, or reference home, in EPA's New Homes program. Since ResNet does not currently apply to high-rise buildings, ASHRAE is the baseline standard used in this program. Not all HERS raters are well-versed on the actual details of the ResNet standard, since most software approved for HERS ratings, such as REM rate and energy gauge, automatically generate the baseline based on the characteristics of the proposed design that is being modeled. Only some software currently auto-generate the ASHRAE 90.1 2007 baseline. Due to the modifications needed to properly address multifamily, auto-generation of the baseline may not yet be ideal, but may be offered in the near future. It is important to understand the structure of this standard before learning all of its minimum requirements. The first 4 sections discuss the purpose and scope of the standard and provide useful definitions, abbreviations, and acronyms. The sections that you will refer to regularly as you create your energy models are sections 5, 6, 7, 9, and 10. These sections contain the minimum requirements for a building to comply with the standard, and therefore they represent the components of your baseline building energy model. Section 8 and 11 are not used when creating the models, and Section 12 is simply a consolidated list of reference standards. Each of the main sections are further broken down. Subsection 1 always provides general information, exceptions, and requirements. Subsection 2 defines ASHRAE's compliance paths, but is not used in the EPA's Multifamily High-Rise program. Subsection 4 lists the mandatory provisions for that section, which are a prerequisite in the Multifamily High-Rise program, but not applicable to the energy model. Subsection 5 lists any prescriptive requirements, which are sometimes required if following the EPA's prescriptive path, but never required if following the performance path. Subsection 6, 7, and 8, and subsection 11 are also not used in EPA's program. The following ASHRAE tables are important for creating energy models. You will need to refer to these tables to determine the efficiencies, insulation values, and lighting allowances for your baseline building. Tables 5.5-1 through 5.5-8 list building envelope requirements, one table for each of the 8 climate zones. Tables 6.8.1d, 6.8.1f, and 7.8 list the minimum HVAC and domestic hot water efficiencies for the equipment in the baseline building. Tables 9.4.5 and 9.6.1 list the lighting power densities by space type, both indoors and out. Table 10.8 lists minimum motor efficiencies for different sized motors. Of the 7 appendices of ASHRAE 90.1, only 4 will be regularly used when creating your energy model. These are Appendix A, the rated R value of insulation and assembly U factor determinations, Appendix B, building envelope climate criteria, Appendix D, climatic data, and Appendix G, performance rating method. It is a prerequisite of the program to use Appendix A to determine the R values and U values of assemblies in your proposed design. This maintains consistency among all energy models in the program. For example, by using Table A3.4 of Appendix A, R13 cavity insulation installed in 2x4 16-inch on center wood frame wall with R5 continuous results in an assembly U value of 0.059. It is also a prerequisite of the program to use Appendix B to determine the climate zone where your building is located. This not only determines what envelope requirements will apply to your baseline building, but some prerequisites for heating and cooling equipment also depend on climate zone. A full listing by state and major cities accompanies this map in Appendix B. Your software may automatically select the correct heating and cooling design temperatures based on the nearest city to your location. If not, the climate data in Table D1 of Appendix D can be used. For example, in Baton Rouge, Louisiana, the 99% heating design temperature is 27 degrees Fahrenheit, and the 1% cooling design temperature is 92 degrees Fahrenheit. Since this impacts equipment sizing, it is a prerequisite to compare these temperatures to those used by the mechanical engineer who is providing the heating and cooling equipment sizing calculations. The 11-page Appendix G is critical to creating your baseline and proposed building energy models and determining your performance rating, which is the percent energy cost savings over the baseline in 1 year. This is the ASHRAE method for rating the energy efficiency of building designs that exceed the requirements of the 90.1 standard. We will review Section G3 in greater detail before reviewing the EPA Supplemental Simulation Guidelines. Section G3 provides details on how to develop the baseline based on your proposed design. In order to calculate the performance of the baseline building and proposed building, some modeling requirements need to be followed to establish consistent baselines. Table G3.1 outlines 13 categories, from schedules to actual building components, and how the baseline should be modeled as compared to the proposed. For some categories, such as thermal blocks and space use classifications, the baseline is modeled the same as the proposed. For other categories, such as envelope and lighting, you are referred to sections in the standard to obtain the characteristics of the baseline. For example, the baseline U values are obtained from Tables 5.5, depending on the climate zone where your building is located. Regardless of your proposed building construction or climate zone, all baseline buildings must use U values for roofs that have insulation entirely above deck and a reflectivity of 0.30. All baseline above-grade walls must be modeled as steel framed. All floors must be modeled as steel joist floors. Floor perimeters must be modeled using U values for a mass wall in that climate zone. Even if your proposed design is wood frame with an attic, the baseline building will have this construction, and the baseline insulation will be selected based on this construction type. As for window area, for buildings where windows are less than 40% of the gross above-grade wall area, the baseline and proposed models will have the same window area and same orientation. If your proposed building has more than 40% window area, the baseline building model will be capped at 40%, and the proposed building model will use what is in the actual design. All window area over 40% in the proposed design will therefore be compared to an insulated steel frame wall rather than a baseline window. Tables 5.5 have 3 categories: residential, non-residential, and semi-heated. Only envelope components of the actual dwelling units are deemed residential in the model. Most common area envelope components should be modeled based on the non-residential requirements. To give you an idea of what the building envelope would look like in the ASHRAE baseline building energy model, here are the requirements for the residential parts of a multifamily building in climate zone 3. A proposed design in this climate zone will be compared to a steel frame building with R20 continuous at the roof deck, R13 in the steel stud above grade wall cavity, and an additional R7.5 continuous. At the floor perimeter, only R9.5 continuous will be modeled. All baseline windows, regardless of frame material in the proposed design, will have a solar heat gain coefficient of 0.25, and the baseline U values will depend on the proposed framing material. Generally, the requirements of the building envelope in the non-residential areas are the same or slightly less stringent. Like the building envelope, the HVAC system modeled in the baseline is not quite apples to apples. Using Table G3.1.1a, residential buildings must use either System 1 or System 2 in their baseline building model. System 1 is used if the source of space heating is fossil fuel based, a hybrid of fossil fuel and electric, or purchased heat. System 2 is used in the baseline if the source is electric or other, or if no heating system is to be provided. The baseline will generally only have one type of HVAC system, regardless if the proposed has multiple systems. For example, if electric heat pumps serve corridors and common areas in your building, but dwelling units are heated with gas furnaces, the baseline system type for all spaces in the building is still Type 1. However, if this conditioned area happens to exceed 20,000 square feet, then Appendix G would permit the baseline to be modeled with Type 1 for the dwelling units, and then Type 2 for these common area spaces. System 1 is usually 1 or 2 hot water fossil fuel boilers. The quantity depends on the size of the building. These boilers are paired with packaged terminal air conditioners to provide forced air distribution for both heating and cooling. The minimum efficiencies for the boilers are found in Table 6.8.1f, and the minimum efficiencies for the PTACs are found in Table 6.8.1d. Efficiencies are dependent on equipment size, and in the case of the boilers, fuel type. Auxiliary components, such as circulating pumps, and design criteria, such as temperatures, are also governed by sections in Appendix G. System 2 is a packaged terminal heat pump that provides both heating and cooling. The minimum efficiencies for the packaged terminal heat pump are also found in Table 6.8.1d and are dependent on size. The example here shows this type of equation used to determine the EAR for various size heat pumps. The capacity used in the equation can only be a value between 7,000 and 15,000 BTU per hour. In System 2, the switch to electric resistant auxiliary heating can only happen when the outdoor temperature is less than 40 degrees. For both system types, the blower motor providing the forced air distribution in the baseline PTAC or baseline packaged terminal heat pump is based on the CFM. The PTAC that provides 400 CFM in the proposed design will consume 120 watts in the baseline. Based on that review of ASHRAE Standard 90.1, we can now review the EPA's supplemental modeling document, the Simulation Guidelines. Although Appendix G provides protocols for modeling performance that exceeds ASHRAE 90.1, the EPA's Simulation Guidelines provides additional guidance for multifamily buildings, where Appendix G does not have sufficient detail. Similar to understanding ASHRAE, it is important to understand the structure of the Simulation Guidelines. The guidelines begin with a list of definitions, and the first two sections quickly review the scope and objectives of the document. The third and largest section covers the modeling guidelines. Appendix A summarizes all reference standards and data sources, and Appendix B provides a description of the performance path calculator. Again, there's a separate webinar on how to use that Excel-based tool. There are 16 sections to the modeling guidelines: general approach, performance rating, simulation program, opaque assemblies, vertical fenestration, lighting, thermal blocks, HVAC, domestic hot water systems, plug loads, elevator loads, ventilation and infiltration, HVAC distribution losses, fan motor energy, pumps, and energy rates. As you can see, some of these categories were somewhat addressed by ASHRAE 90.1, such as HVAC, and some are new, such as plug loads. We won't review each one in its entirety, but we'll try and highlight important items in each section. Energy modelers should be familiar with the entire Simulation Guidelines document before developing performance path energy models. As we've mentioned before, components of the baseline building model shall comply with ASHRAE Standard 90.1/2007. End uses that do not exist in the proposed building cannot be included in the baseline building. For example, if the parking lot in the proposed design is not lit, then parking lot lighting power allowances cannot be added to the baseline building. Components in the proposed design must reflect the actual proposed building components, except where otherwise specified in the simulation guidelines. For example, if your proposed building has no cooling specified, cooling must still be modeled. We'll discuss that more later. Components in the proposed design must comply with the prerequisites of this program as well as applicable state and local codes. Unless otherwise noted in this document, components in the as-built model must reflect the actual installed building components, as verified or measured during inspections. Components that are not required to reflect as-built conditions within the energy model, such as measured envelope leakage, are specified in the relevant sections. Although some measured components are not simulated in the energy model, they do have restrictions as described in the prerequisites. What to include and what to exclude. The baseline building and proposed design shall include all in-unit and residential associated common spaces in the building. All end-use loads associated with the building must be modeled. This includes parking lot and facade lighting, garage ventilation systems, and swimming pools. Commercial or retail spaces that are privately operated or open to the general public may be included or excluded from the simulations at the discretion of the energy modeler. If included in the simulation and the space classification is not known, the space shall be categorized as an office space. Some may choose to include the space based on the requirements of other programs. Including the space enables you to take credit for any improvements to that space that result in energy cost savings. Some may decide to exclude this commercial space if they have no control over the measures installed in those spaces. The decision is left to the design team. Energy-related features that have not yet been designed or installed in those spaces must be modeled the same in the proposed as they are in the baseline. For example, if you decide to model a retail space and HVAC is provided, but not the lighting system, you may take credit for the installed HVAC system, but the lighting must be modeled identical to the baseline. The schedules described within the simulation guidelines for lighting and thermostat settings must be used. The same schedules must be used in both the baseline building and proposed design, unless explicitly allowed otherwise in Appendix G or in this document. Any differences in schedules must be documented. Schedules deemed equivalent to those provided in the simulation guidelines may also be used with prior approval. To determine the performance rating, the baseline building performance and proposed building performance must each be calculated as the sum of the energy costs predicted by the software in a given year. For example, if after entering all baseline and proposed building components and fuel prices, the software determines that the baseline will have annual energy costs of $100,000, that is your baseline building performance. A proposed building performance of $15,000 less, or $85,000 total, would result in a performance rating of 15%. Although the proposed building performance can include energy cost savings associated with on-site power generation, these cost savings cannot be used to meet the 15% performance target to earn the Energy Star. Some performance rating systems are based on site energy or source energy. ASHRAE's is based on energy costs. Some modeling software cannot calculate energy usage for all types of technologies proposed for high-rise multifamily buildings. Energy use for these features can be determined using separate calculators, custom software, spreadsheets, or other means of estimating the energy impact of those features. When calculations of this nature are completed outside of the primary modeling tool, the modeler must document both the basis for the calculation and how it was incorporated into the final performance rating. Calculations performed outside of the primary modeling tool and not described in the simulation guidelines must be submitted to the EPA for review and approval. The computer software that you use to create the building energy models must meet the requirements of Appendix G, Section G2.2. Although not limited to this list, programs such as DOE2, eQuest, Trace, HAP, Energy Gauge meet these requirements. Section G2 of Appendix G also outlines the specific software requirements that must be met in order for a software program to be approved for use with Appendix G, and therefore the multifamily high-rise program. As discussed before, baseline requirements for opaque assemblies such as walls and roofs follow the envelope requirements from tables 5.5 and ASHRAE 90.1, and thermal properties of the envelope components specified in the proposed design must be calculated using Appendix A. For existing buildings that undergo substantial renovations, the opaque assemblies in the baseline building shall reflect the existing envelope conditions prior to any renovations that are part of the scope of work being evaluated. This is based on requirements in Appendix G. This requirement applies to the thermal properties and areas of the different envelope components. For example, if window area was changed as part of the renovation, the pre-retrofit window area shall be modeled in the baseline, and post-retrofit window area shall be modeled in the proposed design. If the pre-retrofit window was a single pane window, thermal properties of that are used in the baseline. Suggested values for unlabeled windows are available in ASHRAE's Appendix A. Through-wall air conditioner sleeves shall be modeled in the baseline and proposed with the U factor required in Table 5.5 for windows with metal framing. Although an insulated cover for these units is required by the prerequisites, the same U factor shall be used in both models since the insulated cover is not used every day. Doors that are more than 50% glass are also treated like windows, per ASHRAE. Assemblies such as balconies, perimeter edges of floor slabs, and concrete floor beams over parking garages shall be separately modeled in the proposed design and must be modeled in the baseline building as having the U factor required in Table 5.5 for mass walls. So even if your proposed design is wood frame construction, the baseline will be modeled with insulation at the floor perimeter edges that are required by ASHRAE for masonry wall construction in your climate zone. Although the different thermal properties of your floor to ceiling wall assembly and your floor perimeter area must be accounted for in the model, a weighted average of the differing U factors of these assemblies is acceptable in the simulation. Continuous exterior insulation must be derated if frequently interrupted by metal shelf angles. Unlike previous versions of ASHRAE 90.1, window area shall now be distributed on each face of the baseline building in the same proportion as the proposed design. As mentioned before, baseline window area cannot exceed 40% of the gross above grade wall area. It can only be exceeded in the proposed design. In Appendix G, if your proposed design has non-metal framed windows, so does your baseline. Likewise, if you are using metal framed windows, so does your baseline. Unlike ASHRAE in the multifamily high-rise program, when the proposed design is a wood frame building, properties of the baseline windows shall be based on prescriptive requirements for windows with non-metal framing, even if metal framed windows are called for in the design. For other building types, baseline window properties shall be based on prescriptive requirements for the applicable metal framing. The intent of this is to promote the use of high-performing windows with non-metal framing and allow credit for not only that design choice, but its improved performance. For example, if following Appendix G, a masonry building that opts to use metal-framed windows will be compared to a baseline that also uses metal-framed windows. If they instead choose to use higher-performing fiberglass-framed windows, their baseline becomes unfairly more stringent. By establishing that the baseline still has metal windows regardless, they get full credit for their design choice. Items throughout this presentation where the EPA has slightly deviated from ASHRAE are marked with an asterisk. For the proposed design, the window properties specified in the drawing shall be used until confirmed on site. These properties must include rated assembly U factor, not center of glass, and solar heat gain coefficient, as shown on the NFRC label or certification provided by the installer or supplier. Automatically controlled window shades or blinds and permanent shading devices such as fins, overhangs, or balconies may be accounted for to calculate energy savings in the proposed design. These should not be included in the baseline. Moving on to lighting, the installed lighting power in the proposed design is typically not equal to just the wattage of the bulbs and must include power conserved by the ballast. Appendix B of the Performance Path document provides typical values for ballast. If following ASHRAE, fixtures with screw-based sockets must be modeled based on the maximum labeled wattage for the fixture, regardless of the lamp installed. This is not a requirement in the multifamily high-rise program. An installed lamp wattage may be used. For example, a screw-based fixture rated for 100 watts maximum with an Energy Star qualified 26 watt CFL installed may be modeled as 28 watts, which includes power consumed by the ballast. This deviation from ASHRAE is being permitted based on the pending phase-out of inefficient incandescent fixtures through the Energy Independence and Security Act, and to enable design teams to install screw-based fixtures that may see a greater availability of even higher efficiency lamps in the future compared to their pin-type counterparts. Lighting energy savings may be claimed only for hardwired installed lighting fixtures, not for any fixtures that are provided in switch outlets. Lighting energy savings may be claimed for the reduced power density only if the proposed fixtures used meet the recommended light levels for the given space type. As a reminder, the Illuminating Engineering Society's foot candle recommendations for spaces commonly found in multifamily high-rise building have been listed for your convenience in a table in the Performance Path document, and the Performance Path Calculator has a worksheet that will help you determine if light levels are being met. Baseline and proposed design lighting inside units shall be modeled as lit for 2.34 hours per day. Balcony lighting shall use the same schedule as the dwelling units. Performance credit for occupancy, motion, or photosensors may not be claimed for in-unit lighting. In the baseline building, you must model in-unit lighting based on 1.1 watts per square feet. In the proposed design, model in-unit lighting based on 1.1 watts per square feet only in rooms or portions of rooms with no specified hardwired lighting. For example, bedrooms with switched outlets in the proposed design would be modeled with 1.1 watts per square foot in both baseline and proposed models. Where hardwired in-unit lighting is specified in the proposed design, the actual installed lighting power density shall be modeled. This lighting power density must take into account the total effective floor area of rooms or portions of rooms in which they are intended. Hardwired fixtures in rooms that will be supplemented by lighting that is connected to receptacles can be estimated to provide illumination at a rate of no more than 2 feet squared per watt. This is illustrated in the following slides. The overall lighting power density can be calculated first before entering it into any model. This floor plan is not drawn to scale, but demonstrates the calculations. The total square footage of the apartment is 950 square feet, so the baseline is modeled with 1,045 watts. If a room is designed with a hardwired fixture that is not intended to provide full illumination for the space, then supplemental lighting will need to be provided by the occupant. That supplemental lighting must be calculated as 1.1 watts per square foot in the proposed design. The installed lighting can only apply to 2 square feet per watt of installed lighting. So if 100 watts of energy efficient lighting is installed in the 300 square foot living room, it can at most illuminate 200 square feet, leaving 100 square feet to be lit by supplemental lighting provided by the occupant. This lighting cannot be assumed to light the entire 300 square feet. If a room is designed with a hardwired fixture and is intended to provide full illumination for that space without any supplemental lighting, like in a kitchen, hallway, or bathroom, the installed lighting power can be modeled as is, as long as it meets the foot candle requirements. Summing all installed lighting power and the default for areas with no hardwired lighting, and dividing by square footage gives us an overall lighting power density that we can use in the proposed design model. Lighting power densities for common area spaces in the baseline building are based on Table 9.6.1 of ASHRAE. Baseline lighting in corridors, stairwells, lobbies, and elevators shall be modeled as being lit for 24 hours per day. Hours of operation in any other areas may be estimated by the energy modeler based on occupancy type for each space and shall reflect the mandatory control requirements of ASHRAE. Some suggested schedules are listed in this table. Since automatic lighting controls are a baseline requirement for most common area spaces in ASHRAE, very few spaces have a 24-hour operating schedule. Performance credit may be claimed in the proposed design for installing automatic controls where such controls are not required, such as in corridors, stairwells, and lobbies, which are considered intended for 24-hour use. Performance credit can be taken either by reducing the modeled lighting power density or by reducing the lighting hours of operation. Table G3.2 of Appendix G describes the amount of credit you can take for automatic controls in eligible spaces in your proposed design. Based on studies of multifamily buildings, the EPA has increased this credit and allows reductions in hours or lighting power density of 25% for corridors with occupancy sensors and 35% for stairwells with occupancy sensors. Performance credit cannot be taken for occupancy sensors in spaces such as laundry rooms or offices, as those are required to have automatic controls. Exterior lighting that is connected to the site utility meters, such as pole fixtures for walkways and parking, exterior lighting attached to the building, shall be included in the baseline building design and proposed design. Baseline lighting power allowance is determined from Table 9.4.5. Exterior lighting performance credit may be claimed only for the areas for which lighting is specified on the drawings. Same example as before, if the parking lot in the proposed design is not lit, then no parking lot lighting power shall be modeled in either the baseline building or proposed design model. In addition, facade lighting in the proposed design that exceeds the baseline allowance must be modeled as a penalty. However, no performance credit can be modeled for reductions in facade lighting below the baseline allowance. If lighting is specified for apartment balconies, the baseline allowance can be determined from the allowance for facade lighting. As with all other lighting, use the lighting worksheets within the Performance Path Calculator for these lighting calculations. Again, a separate webinar is available to review how to use that calculator. Baseline and proposed exterior lighting shall be modeled as lit for no more than 12 hours per day. This includes savings due to photosensors that are required by ASHRAE. When defining thermal blocks in your building energy model, the multifamily high-rise program deviates from certain requirements from Appendix G. Appendix G would not allow aggregation of corner dwelling units with other interior units, would not allow aggregation of dwelling units that have different orientation or are adjacent to different types of surfaces. Under EPA simulation guidelines, this aggregation is allowed but not necessarily required. All other modeling requirements outlined in Appendix G's Table G3.1 for thermal blocks must be followed. For example, common spaces, utility areas, and other non-living areas must be modeled as separate thermal blocks. The thermal block configuration must remain identical between the baseline building and proposed design building models. Every space that is modeled as cooled in the proposed design model shall also be modeled as cooled in the baseline building model. Likewise, every space that is modeled as heated in the proposed design shall also be modeled as heated in the baseline building. Unconditioned spaces shall also match between the proposed design and baseline building models. Model the entire living space, including all dwelling units, offices, community rooms, and other conditioned spaces, as heated and cooled. Even if cooling equipment is not being installed in dwelling units, they must be modeled as being cooled in both models. Equipment efficiencies must match the baseline building when equipment is not specified in the proposed design. Unlike Appendix G, do not model cooling in corridors and utility spaces such as mechanical rooms, laundry rooms, unless the spaces are cooled in the proposed design. All baseline HVAC equipment shall be modeled as per Appendix G as discussed previously. In the model, the baseline equipment capacities shall be oversized by 15% for cooling and 25% for heating as required by Appendix G. This does not apply to the proposed design model. Sizing for equipment in the proposed design must meet program prerequisites, and the proposed design model must reflect that sizing. All baseline HVAC equipment shall be modeled using the minimum efficiency levels as described in Section 6.4 of ASHRAE. The baseline equipment capacity shall be oversized by 15% for cooling and 25% for heating as required by Section G3.1.2.2. In all cases, the same modeling method and efficiency units shall be used in the baseline and proposed model. For example, if thermal efficiency, not AFUE, is used in the baseline building model, then thermal efficiency and not AFUE shall also be used in the proposed design model. The same rule applies to SEER and EAR input for cooling equipment. Set point temperatures of 72 degrees Fahrenheit and setback temperatures of 70 degrees Fahrenheit shall be used for heating. Set point temperatures of 78 degrees Fahrenheit and setback temperatures of 80 degrees Fahrenheit shall be used for cooling. The baseline building model must have setback for both heating and cooling. Unlike HVAC, the baseline domestic hot water system type, capacity, and fuel shall be the same as specified in the proposed design, unless a combination heating and hot water system is specified. In that case, separate standalone systems for both heating and hot water shall be modeled as a baseline system, and they must meet the minimum efficiency requirements for each system. Baseline domestic hot water system efficiencies are listed in Table 7.8 of ASHRAE. Unfired storage tanks in the baseline building must be insulated with a minimum of R12.5. Hot water demand in the baseline building shall be determined based on the number of occupants in the building, assuming one person per bedroom. Per person consumption of 12, 25, or 44 gallons per day shall be used based on low, medium, or high usage based on occupancy demographics. Low per person values are associated with buildings where all occupants work or is primarily housing for seniors or middle income families. High per person usage is associated with buildings with high percentages of children, low income families, or where few occupants are working. For example, a building with 100 occupants where high hot water usage is expected, the baseline will be modeled as consuming 4,400 gallons per day. The hot water demand in the baseline assumes that all plumbing fixtures meet EPAC 1992, or 2.5 gallons per minute for faucets and shower heads. Even though lower flow fixtures, 2.0 gallons per minute, are already required by the prerequisites, the hot water demand in the proposed design may be reduced to take performance credit for those hot water savings. Savings from reduced hot water consumption from specifying Energy Star qualified clothes washers and dishwashers is also permitted. The domestic hot water demand worksheet in the performance path calculator is available to calculate the reduced flow rate from plumbing fixtures and appliances. Although only the thermal energy savings associated with the reduction in hot water usage can be modeled, guidance is available to calculate reduced costs associated with any measure that results in water savings. Although lower water and sewer bills won't impact your performance rating, they can impact the cost effectiveness of water conserving measures. These calculations can also be found in the water savings worksheet of the performance calculator. The same piping area shall be used in the baseline building and proposed design models. A hot water set point capable of delivering a temperature of 120 degrees Fahrenheit at the point of use shall be used in both the baseline building and the proposed design model. If a hot water recirculation system is present in the proposed design, it must also be included in the baseline. Values to be modeled for non-lighting receptacle loads, from specific appliances to miscellaneous plug loads, are included in this section of the simulation guidelines. All such loads, including the fraction of loads contributing to internal heat gain, shall be identical in the baseline building and proposed design models. If dishwashers, clothes washers, or clothes dryers are not specified for the project, they should not be included in either baseline building or proposed design models. However, refrigerators must be modeled in both models, regardless if they are specified in the proposed design. Where annual or daily consumption is provided in the table, it must be converted into the equivalent design load, either watts or watts per square foot, as appropriate for the energy modeling software being used. There is also a worksheet in the Performance Path Calculator that supports these calculations and how to model performance credit for the Energy Star appliances. As you can see in this section of the table, as a simplification, all refrigerators are assumed to consume the same amount in the baseline, regardless of specified size in the proposed. Similarly, the typical consumption of Energy Star qualified appliances were used rather than allowing input for a specific Energy Star model. This was done to simplify the purchasing process and prevent changes to the energy model if a slightly different Energy Star qualified appliance was installed rather than what was initially expected. To determine the electricity consumption of elevators in the baseline building, use the number of stories and units in the proposed building with the chart provided. For example, a 7-story building with 60 units is estimated to use 4,550 kilowatt hours per year. This is similar to 9 standard refrigerators that run 24/7. 10% of the electric energy usage of the elevator shall be added to space heat gain. Use the same value for the proposed design model, or to take credit for an efficient model, follow instructions in the simulation guidelines. Savings related to lighting in the elevator may be claimed as a separate performance credit in the lighting section. When modeling ventilation and infiltration, if the energy modeling software supports multiple infiltration algorithms, The same method must be used in the baseline building and proposed design models. Any default infiltration rates in the software for non-dwelling unit spaces may be used, but must be the same in the baseline building and proposed design model. Process-related exhaust ventilation, including bathroom and kitchen exhaust, trash room exhaust, and laundry room exhaust, may be combined with infiltration in that particular space to determine the combined air exchange rate to be entered into the model. This combined calculation procedure is demonstrated in the infiltration and ventilation worksheet of the Performance PEP calculator. In the as-built model, measured infiltration rates are not used. However, the measured infiltration must comply with the prerequisites. Where ASHRAE Standard 62 is referred to in these guidelines, use ASHRAE 62.2 2007 standards for dwelling unit and ASHRAE 62.1 for all spaces other than dwelling units. The baseline building local exhaust and whole house ventilation rates shall be modeled in the baseline the same as the proposed design, but without exceeding ASHRAE 62.2 by more than 50% in the baseline. If the ventilation in the proposed design exceeds ASHRAE 62.2 by more than 50%, the baseline shall be modeled as 50% greater than ASHRAE 62, but not any higher. For example, since ASHRAE 62.2 only calls for 50 CFM of intermittent ventilation in the bathroom, if the proposed design calls for 100 CFM, the most the baseline will include is 50% extra, or 75 CFM. ASHRAE 62.2 provides an equation or table for you to determine the amount of whole house ventilation needed in units. A 1,000 square foot apartment with 3 bedrooms would need 40 CFM according to the equation. This could be provided on a continuous basis by 2 exhaust fans that are already providing local exhaust in the bathrooms, or it could be provided by setting an intermittent fan on a timer. There are certainly other options as well. Regardless of what amount of mechanical ventilation is designed, the combined modeled rate of mechanical and natural ventilation and infiltration in dwelling units shall be no less than 0.35 air changes per hour or 15 CFM per person. In the previous example, only 40 CFM of mechanical ventilation was designed. However, the model will need at least 60 CFM to also cover the air exchange from infiltration. Although infiltration is a measured value, the measured value is not incorporated into the model. This is due to the fact that tested infiltration includes leakage from conditioned spaces, and modeling software generally requires only leakage from the outdoors. Again, the infiltration and ventilation worksheet in the Performance PEP calculator helps you with all these requirements and calculations. Ventilation control shall be modeled in the baseline where applicable. For example, both outdoor air supply and exhaust systems shall be equipped with motorized dampers to automatically shut when the systems or spaces served are not in use. This requirement applies to common spaces such as community rooms, offices, and laundry rooms. No heat recovery shall be modeled unless it is required by local code or Appendix G. Heat recovery is typically not required for multifamily buildings. No demand control ventilation shall be modeled in the baseline unless required by local or national code. Heat recovery and demand control are typically not required for multifamily buildings. In general, the proposed design model uses the same exact rates as indicated on the drawings, and those rates have to comply with ASHRAE 62 2007. Same as the baseline model, the combined modeled rate of mechanical and natural ventilation and infiltration in the dwelling units cannot be less than 0.35 air changes per hour, or 15 CFM per person, regardless of the measured infiltration. Specified mechanical ventilation is permitted to exceed ASHRAE 62.2 2007 recommendation by up to 50%. Anything greater than that is modeled as an energy penalty. HVAC distribution losses are not currently required in the simulation. Although the program has set minimum insulation requirements and duct leakage restrictions, they are not included in the models. Projects may pursue performance credit for properly sealing central stack ventilation ductwork. To receive this credit, the actual duct leakage measured during the inspection phase of the project as part of the testing and verification protocols must be below 10 CFM per floor per shaft when measured at 50 pascals. To model the energy savings, the actual measured leakage shall be added to exhaust CFM in the proposed design. The exhaust leakage in the base building model shall be modeled by adding 10 CFM per floor per shaft to the specified exhaust CFM. Based on the prerequisites, the actual measured exhaust leakage cannot exceed 10 CFM per floor per shaft. Fan motor energy consumption must be included in the baseline building and proposed design. This includes fans for both ventilation and for heating and cooling distribution. In the baseline building, the fan power for PTAC or package thermal heat pump units must be modeled at 0.3 watts per CFM, as mentioned previously. Supply and exhaust fans that are not part of the heating and cooling system, such as rooftop exhaust fans, laundry makeup air fans, trash room exhaust, garage exhaust, shall be modeled by multiplying fan brake horsepower by 746 and dividing by the motor efficiency. Motor efficiency for the baseline is determined using Table 10.8 of ASHRAE. For baseline exhaust fans, such as range hoods, ceiling and inline exhaust fans, model fan power at a rate of 2.3 CFM per watt for the range hoods and larger fans, and 1.2 CFM per watt for the smaller fans. Fan energy in the proposed design shall be modeled using actual project conditions and parameters of specified equipment, such as fan brake horsepower, fan motor efficiency, and airflow rates. You can take performance credit for fans in the proposed design with higher motor efficiencies than those in the baseline. You can also take credit for any higher efficiency Energy Star qualified exhaust fans that are specified. Fan motor energy savings from demand control ventilation may be modeled by reducing fan runtime in the proposed design as compared to the baseline. For example, reduce fan runtime from installing carbon monoxide sensors in residential associated garages may be modeled using 8 hours per day in the proposed design, compared to 24 hours per day in the baseline. Tenant-operated exhaust fans do not qualify as demand control ventilation and must be modeled with the same runtime in baseline and proposed. If not known, assume 2 hours per day in both energy models. As discussed at the beginning of the webinar, if your baseline building uses HVAC System 1, the hot water boiler, the circulating pumps associated with this baseline system have certain requirements that must be modeled. Some of these were related to supply and return temperatures, outdoor reset control, and assumed power consumption of the pump motor itself. Pumps in the proposed design shall be modeled using the actual system parameters including head, capacity control, and pump motor efficiency. Proposed pump motors can generally get some credit over the baseline pump motors due to the prerequisite requiring NEMA premium pump motors. Pump controls generally also result in performance credit, except when control is already required in the baseline. For example, gas-heated buildings over 120,000 square feet must be modeled with pumps that have variable speed drives in the baseline. If the pump motor is not included in the scope of ASHRAE 90.1, Section 10, the pump does not have to be modeled explicitly. If included in the model anyway, its parameters shall be used the same in the baseline as it is in the proposed model. Use state average energy prices in all simulations. These are published by the Department of Energy's Energy Information Administration. Actual rate schedules and pricing may be used if and only if savings associated with the demand reduction are modeled. In this case, supporting documentation must be provided showing monthly pricing for 12 consecutive months. Performance credit for the reduced energy cost may be claimed only if the cost reduction is due to the reduced energy consumption or demand. Following this rule, energy cost savings associated with submetering must not be included in the performance rating. This concludes this webinar on the simulation guidelines. You should have a better understanding of how to apply Appendix G and the simulation guidelines to your energy models and how to determine your performance rating. After completing a model, use the modeling checklist, a Word-based document available on the Multifamily High-Rise website, to check your own work and confirm that model inputs align with the simulation guidelines. To learn more about the Performance Path Calculator, download the Excel file available on the website and view the corresponding webinar. If you have questions about the simulation guidelines, please visit our website for more information or email us at mfhr@energystar.gov.